Hi there! If you're having trouble with question 6 of Calc BC's 2011 FRQ, or you're Mr. Shay, you are probably in the right place, but if you meet neither of those criteria, you may want to leave now. You could also not do that, it's really up to you. Anyway, so we'll be going over each part of the question in detail, so don't worry if you don't have a chance to read it all now. The premise of the question is that f of x is equal to sine of x squared plus cosine of x, and the graph on the right is that of the absolute value of the fifth derivative of f of x. So you'll see it again in the relevant part of the question, but that said, let's go to part A. So part A wants you to write the first four non-zero terms of the Taylor series for sine of x about x equals 0, so that's the Maclaurin series for sine of x, and write the first four non-zero terms of the Taylor series for sine of x squared about x equals 0 as well. And we'll just look at how we're doing that. So in order to do this problem quickly, you'll need to have memorized the Maclaurin series formula for sine of x. Here it is. You can see that sine of x is equal to the sum from 0 to infinity of -1 to the n times x to the 2n plus 1 all over 2n plus 1 factorial. But if you don't remember the formula, you can just derive it using the general formula for a Taylor series. Let's be real though, because by now if you haven't memorized your 6 Maclaurin formulas, you're in for kind of a world of suffering, so just spare yourself the tears and memorize them. So plugging in our n values into the formula, we can see that when n equals 0, the first term is x. When n equals 1, the second term is -1/6 x cubed. When n equals 2, the third term is x to the 5th over 120. And when n equals 3, the fourth term is -x to the 7th all over 7 factorial. So recall that the fourth term doesn't necessarily mean the fourth degree term or where n equals 4, since n here starts at 0 and not 1. Anyway, so you'll stick the four terms together and you'll end up with the four-term approximation of sine x using your Maclaurin series, or your Taylor series around x equals 0. Now the question asks you to find the four-term approximation of sine of x squared. So you should save yourself some work here and really just change every x that you have to x squared. X becomes x squared, -1/6 x cubed becomes -1/6 x to the 6th, 1 over 120 x to the 5th becomes 1 over 120 x to the 10th, and -1 over 7 factorial x to the 7th becomes -1 over 7 factorial x to the 14th. Once we put the four together, we'll have the four-term approximation for sine of x squared, and that's the one that you see right there. Part B is asking you to do a very similar thing. It wants you to put the first four non-zero terms of the Taylor series for cosine of x about x equals 0, and then it wants you to use that series and then the series for sine of x squared, that's the one that you just found in part A, to write the first four non-zero terms of the Taylor series for f about 0. So again, to solve part B, you're going to need to know the 6 basic Maclaurin formulas, and this one's for cosine of x. The sum from 0 to infinity of -1 to the n times x to the 2n over 2n factorial. And we can see that plugging in gives you 1 when n equals 0, -1/2 x squared when n equals 1, 1 over 24 x to the 4th when n equals 2, and -1 over 6 factorial x to the 6th when n equals 3. And that results in this four-term approximation for cosine of x that you see right here. So now you have to add together the two four-term approximations to find the four-term approximation for f of x. And we see that the 1 and the 1/24 x to the 4th stay the same here because they're only found in cosine of x. But there's overlap in the second and 6th degree terms. And since we're doing only the fourth term approximation, we'll go ahead and drop the 10th and 14th degrees from sine of x squared. So this leaves us, once we do our addition, with the four-term approximation. F of x is roughly equivalent to 1 plus 1/2 x squared plus 1/24 x to the 4th minus 121 over 6 factorial x to the 6th. Part C is going to be the most simple part of the problem. It just wants us to find the value of the 6th derivative of f of x at x equals 0. We could literally derive f of x 6 times, but A, that would be extraordinarily time-consuming, and B, it would be completely missing the point of the Taylor series problem. Since part C only gives you 1 point for the answer, you could probably get away with it on the exam, but there's really no reason that you should. Recall instead that the formula for Maclaurin series is the following. So the nth term will be the expression on the right with a numerical n plugged in. And in this case, we're going to plug in 6. So if we want to isolate the sixth derivative of f of x at x equals 0, we can set that expression that you just saw equal to f of x's sixth degree term. We'll use simple algebra to isolate the sixth derivative of f of x here, and then we'll see that it's equal to negative 121. That's really the least painful part of the problem. If you're having difficulty with that, I'll suggest a few problems near the end that you might want to look at. Part D is probably the most work-intensive part of the problem. It wants you to let P4 of x be the fourth degree Taylor polynomial for f around x equals 0, and then using information from the graph of the absolute value of the fifth derivative of x, shown above, you're going to show that the absolute value of P4 of 1/4 minus f of 1/4 is less than 1 over 3,000. So here we're looking pretty clearly at Lagrange error. So we want to find what that means is the fourth degree Taylor polynomial from the actual function on the interval 0 to 1/4. We're literally given 1/4 in the problem, so that helps us out some with figuring out what our interval is. 0 is the other end because that's the center of the Maclaurin polynomial. And you'll remember that the formula for Lagrange error looks like this right here, where m is the maximum of the absolute value on the n+1th derivative of f of x on the given interval. And since Lagrange error is essentially distance, right, it has to be positive. The formula is going to ask us to use the graph given, so it's a safe bet that we'll be using it and not finding still more terms of the approximation, which is another way we could technically solve but really shouldn't in our Lagrange error. We'll start by plugging in our n values. So here n actually refers to degree for once, so we're going to plug in 4 for n. And x, since we're working for the x, the greatest distance from a equals 0 is going to be the end of our interval, 1/4. But when we find the maximum for m on the interval, we legitimately are just estimating here. The line falls somewhere in between 20 and 40 at its highest point between 0 and 1/4, but we can't see exactly where that point is, so we're just going to err on the side of over-approximation. We'll call m 40. Now, plugging in m and simplifying somewhat, we can use number sense to realize that 1 over 3 times 4 to the 5th is definitely going to be less than 1 over 3,000. So the approximation didn't yield an exact value for f of x, obviously, but Lagrange error allows us to see just how far away it got. So yeah, our task failed successfully. Anyway, thanks for watching, and I really hope you enjoyed this look at AP Calc BC's 2011 FRQ question 6. For more serious questions like this, you should check out the link in the description for a document of question numbers that match up with each part of the FRQ. For more videos like this, click like and okay, no, I'm not going there. Please do not subscribe. I only ever post instructional videos, so unless you have a passion for middle and high school subjects, there's really not that much here for you. Anyway, I'll see you around.